In this video, we are going to cover what functions are. Function is a word that we use a lot in math. You all heard me use the word, but we haven't actually defined it. We've taken the word for granted without defining it. And so this is the portion of the class where we no longer take the word function for granted. We are actually going to define what a function is. So in this video, I'm going to be showing you, I'm going to define what a function is, and then I'm going to give some examples of functions, and then I'm going to give some non-examples. What are some things that might look like functions, but they're not actually functions? So without further ado, let's get started. So the definition of a function, this is the definition. In mathematics, I'll just say in math, a function is a special relationship. It's a special relationship between inputs and outputs. Inputs and outputs. Whoops, I keep spelling stuff wrong. That's not all. That's part of the definition. So far, in math, a function is a special relationship between inputs, plural, and outputs. Each input has exactly one output. That's a requirement of functions. So if you have some sort of mathematical relationship between inputs and outputs, but for some input you have two outputs, it's officially not a function. So this is where some people may get tripped up in the future. I guarantee you I'm gonna ask you all what is a function versus what is not a function. And I'm going to give you all an example of a mathematical relationship where you have some set of input, you have some input, and it has multiple outputs. The minute you see two outputs for a single input, you know it's not a function. All right. And we'll cover this some more in this video. But I just wanted to give you all that quick synopsis. So the inputs, the list, the set of all inputs is known as the domain. The set of all inputs is known as the domain. The set of all outputs is known as the codomain, or the range. So let's write that down too. The set of all outputs is known as the codomain, aka the range. Okay. So, and I'll square that off too. So, right. So far, we got the definition of a function. In math, a function is a special relationship between inputs and outputs. Each input has exactly one output. We also have the definition of the domain of a function. The domain of a function is the set of all inputs. And then we have a definition for the codomain, or the range of a function. And that's the set of all outputs. Now let's get down to some examples. Let's go move on to some examples. Let's say I have y equals x squared. This is a relationship. This is a special mathematical relationship, and it is a function. Let's see why. I'm going to create a domain of inputs. I'm going to define my domain as x is all real numbers. So x belongs to x is the sets of all real numbers. X is the set of all real numbers. Okay. This double R, this R right here, that means the real number system. So X is any number within a real number system. That's my domain. So those are the inputs that I can put in. So I can put in 1, I can put in pi, I can put in 12, I can put in, I can't put in I because I is not in the real numbers system. I is a part of the complex number system. So, but any real number I can put in, that can be my input, any real number. So let's explore this relationship a little bit. Let's explore this mathematical relationship between inputs and outputs. Let's say my input is 1. If my input is 1, then what I have is y equals 1 squared. If my input is 1, then I have y equals 1 squared. And if y equals 1 squared, then y is just equal to 1 because 1 squared equals 1. So what does that mean? What does that mean? My input was 1. I made x equal to 1. My input was 1. And my output was 1. Another way of saying this is 1 maps to 1. Now let's do another example. Let's say my input is 2. Then I would have y equals 2 squared, which is equal to 4. Okay. So when 2 is my input, 4 is my output. When I input 2 as the value of x, my result is 4. So another way of saying that is this function we have, y equals x squared, this function we have takes 2 and maps it to 4. And then we could do a couple other examples. We could do like, let's say -3. Let's say -3 is my input. Then I'll have -3 squared, which is equal to 9. Okay. And what that means is 3 maps to 9. -3. -3 maps to 9. When -3 is my input, 9 is my output. These are one-to-one relationships. For every input, I have exactly 1 output. Now, there are some examples where there's 2 inputs that map to the same output. So let's do, we already did -3 as an input. Let's do 3 as an input. If 3 is my input, then 3 squared is what my output is going to be. 3 squared is just equal to 9. So 3 maps to 9. This is perfectly okay. This input, it maps to a single output. Now, that single output just so happens to be the same output that this -3 input maps to. But that's okay. 2 inputs can map to the same output. 2 inputs can map to the same output. And that's okay. It's still a function. What's not okay, what breaks the definition we have, is if one input maps to two outputs. Two inputs can map to a single output, as is the case here, and that's okay. It's still a function. But if one input maps to two outputs, so let's say my function was y equals positive or negative x. Let's say this is my function, quote unquote function. Let's say this is my equation. This equation, if x is equal to 3, let's say x is equal to 3. If x is equal to 3, then y is equal to positive 3 or negative 3. This one input maps to two outputs. In our definition, a function is each input has exactly one output. So this breaks our definition. This input has two outputs, not allowed, and so it's not a function. So what does this look like graphically? What does it look like graphically? How does identifying whether something is a function or is not a function, how does that look graphically? Let's see. So remember we had x squared. So in red, I'm gonna graph y equals x squared. And that's gonna look something like this. It's gonna look something like this. That's a parabola. We learned about that. That's a parabola. And for each input, for each value of x on this graph, let's say you pick this x value, or let's say you pick this x value, this point on the graph. Say you pick this point on the graph. The x coordinate is going to be whatever lands right here, and the y coordinate is going to be whatever this value is. So let's just say, x is 3, y is 9, all right, for the sake of us having a concrete example. For every x value, there's only one y value. If I slide over to a different x value, let's say x equals 2, then my y value on this graph is just gonna be 4, and there's just one y value. So this makes sense. This is a function. It makes sense that we have one y value for every x value. Let me show you a non-example of a function. How would that look graphically if you graph a mathematical relationship that's not actually a function? So let's say the graph looks like this. It looks like a parabola, but instead of it being vertical, it's horizontal. Let's pick an x value. Let's say x equals, 3 or something. There are two y values for this x value. There's this one, and then there's this one below. This one x value has two y values. There's this y value. This is some y value here. And then there's this y value of this point. This point here has some y value. This point here has some y value. These 2 points have the same x value though. So one x value yields two y values. This is a non-example, so this is not a function. This is not a function. It's an equation probably, but it's not a function. So graphically, you can determine whether or not something is a function two ways. You can find an example where you got two inputs that, where you got one input that gets you two different outputs. So like in this case, where you got one input that gets you two outputs. And once you see two outputs for a single input, you know it's not a function. Or you can analyze things graphically using something called the vertical line test. The vertical line test states if there is anywhere on the graph where you can draw a vertical line, a perfectly vertical line, and you hit two spots on the graph, then it's not a function. So in this case, the vertical line test fails here. I draw a vertical line, I hit 2 points on the graph. So I draw this vertical line and I hit this point and I hit this point. So this is not a function. And it fails here. I draw a vertical line here and it hits this point and hits this point. It only has to fail one time, by the way. So the minute I found a single example of a vertical line that can be drawn that hits 2 points on the graph, I know for a fact it's not a function. I'll give you another example of a non-function. So, this is an example of another non-function. And this is not a function because here, there's one spot here. Imagine this is just one little spot. Imagine there's just one itty bitty spot. Actually, I'll write it so that you don't even have to imagine so much. If this is my line, right? This is my graph. And I got this little wrinkle in the graph. And this spot here, this is a single spot where there are two. If I draw a vertical line anywhere on this graph, if I draw it here, doesn't fail the vertical line test because it only hits this graph once. This is my axis. So this is my y-axis. This is my x-axis. And then this is my graph. The vertical line test passes here. It passes pretty much everywhere except this one itty bitty spot. This one itty bitty spot is where if I draw a vertical line here, I'm going to hit two spots on the graph. So it fails. This entire graph fails the vertical line test. This whole thing is not a function because of that one little vertical line test fail here. Everywhere else, the vertical line test would pass, but in this one little spot, it fails the vertical line test. And all you need is one failure point for this whole graph to not be a function. So this is not a function. Okay. So there's two ways. Let's do a quick summary. This video is getting a little longer than what I anticipated. Sue me. All right. So a quick little summary. There is the domain of a function. The domain of a function is the set of all. Actually, I don't need to rewrite it because it's already written. So the domain of a function, or the definition of a function first, let's start there. In math, a function is a special relationship between inputs and outputs. Each input has exactly one output. The minute you see an input that has two outputs, even if it's only one, even if there's millions and millions or billions of inputs and only one of those inputs have two outputs, the minute you see a single input that has two outputs, it is not a function. And you can make that determination two ways. You can make that determination graphically, or you can make that determination by analyzing whatever your mathematical relationship is, whatever your mathematical equation is. So The domain of a function is the set of all inputs. You can have a domain that includes an infinite number of values. One example is this domain here. X is the set of all real numbers. This is me defining the domain for this function here. And so all real numbers, there's an infinite number of real numbers. And so X has an infinite number of elements in its domain. The codomain, or the range, as many people refer to it, the codomain is the set of all outputs. So if I look at this function here, it'll never have a negative number because we're squaring whatever our input is. If our input is -3, then -3 squared is +9. If our input is -100, then -100 squared is +10,000. So our range, our output for this function here, our codomain is all of the positive numbers. And this is how we would write our codomain. Y is the set of all non-negative real numbers. So for this particular example here, X is our domain. Our domain is the set of all real numbers. Our range is the set of all non-negative real numbers, which makes sense. Our input can be any real number from -infinity to +infinity. And so that makes sense why X is the set of all real numbers. And then our output, it can't be negative because we're squaring whatever our input is. And anytime you square two real numbers, you get a positive number. So Y, our range, our codomain is all the non-negative numbers. So, and lastly, a quick review on how we analyze graphs to determine whether or not the graph is a function or not. And we analyze graphs using something called the vertical line test. The vertical line test states if you can draw a vertical line on any point of the graph and that vertical line intersects the graph in two places, then it's not a function. So in this case, in y equals x squared, we determined that y equals x squared is a function. Let's take a look at the graph to see why. Why is it a function? Because there is nowhere on this graph where I could draw a vertical line and I intersect this graph in two locations. So here, I can't draw a vertical line and intersect this graph in two locations. And that makes sense. That's what's necessary in order for it to be considered a function. But then if we consider this graph has many, many, many places that I can draw a vertical line and intersect the graph in multiple spots. Now, it doesn't need to have many. All it needs to have is one vertical line, one example of a vertical line that can be drawn such that the line intersects the graph in two spots, two locations. The minute you have that single example, then it's not a function. And so this is not a function for that reason. And then this one is not a function for that reason. That's it for this video. Hope you enjoyed it. Peace.